Okay, YouTube, in this video we are going to introduce the concept of a vector and then talk about what we mean when we sketch vectors both in standard position as well as find their component form. Okay, so starting off, we're going to go ahead and introduce what a vector is. We say any quantity that has both a magnitude and a direction. We're going to call this magnitude represented by length. But basically, anything that is a vector has a magnitude and a direction, or a length and a direction. So you see several different instances of vectors here, but I would say that the very first picture that I want to point out here is that we have this vector u and vector v. Now, in terms of u and v, you notice here that they're both going in the same direction, and they both have the same exact length or magnitude. So we say that two vectors, as long as they have the same magnitude and the same length, for all intents and purposes, they are the same exact vector. So it doesn't matter where they are located in the two-dimensional plane here. As long as they have the same direction, same magnitude, and then the same vector. While I'm at it, you notice that I use u and v here. Often, when we write the letters or the names of vectors, we use lowercase boldface letters to indicate that it is a vector. When you don't have boldface letters available to you, sometimes you will see the letter with an arrow on top of it, which would indicate that it's a vector. You'll see an arrow like that sometimes, and sometimes you'll see an arrow like this. But these are both vectors, u and v, and they are equal because they have the same direction, same magnitude. In the second picture here, you'll notice that they have the same length or same magnitude but different directions, okay? So that does actually make a difference which side the vector starts on and which side it ends at, okay? You can tell always by the arrow. Below the very first instance here, these two are the same direction but different magnitudes. And then in this last particular instance, we say that these would be two vectors that have, of course, different directions and different magnitudes, okay? So let's go ahead and discuss positioning vectors in standard position. We say a vector, if it is placed on a standard coordinate plane with its tail or initial point, so we're going to give this a name here. This is the initial point of the vector. It means where it starts. If the tail is at the origin, it's its initial point, then we say the vector is said to be in standard position. That's the only stipulation for it. So long as it starts here, it's in standard position. We're actually going to give this a name here. This would be its terminal point. And this is where it stops. Okay, so we have the initial and terminal point. And the reason why we like things in standard position so much is because, let's imagine that I drew some other vector here, and I'm trying to draw this with the same magnitude and same direction. If I had to describe to you what this vector is, I would have to tell you 2 points. One where it started, we'd say x1, comma y1, and another point where it stopped, x2, y2. Whereas if I were to put a vector in standard position, we assume that it starts at 0, 0. So in terms of telling you about this vector, all I would have to do is really tell you where it ends because, well, let's face it, we already assume that it starts at 0, 0. So given the fact that two vectors are equal, if and only if they have the same direction, same magnitude, if I had a vector like this right here, one thing that I would seek to do would be to write it in component form and assume that it is at the origin. That is to say, if I were to imagine that it has two components here, it has a horizontal component and a vertical component, that would be the same horizontal and vertical component that I would get with this triangle right here. So really what we're looking for is just this horizontal and vertical component of this vector right here. Okay, so we say a vector in standard position is said to be in component form. That is, anything starting at 0, 0 is in component form because I just have to tell you where it ends. So component form assumes that your vector is in standard position or starts at the origin. And we say to get any vector into component form, we're going to use this right here. Now notice, this is very important, that we're writing these little cusps right here. When you write something in a cusp-like form, what you are saying is that we have some vector that is in standard position. I'm going to draw on some random vector here. We say this is my vector. And we say that it is in component form if it starts at the origin. So what this is basically communicating is that since we're assuming it starts at the origin, you can tell because there are these cusps around it right here, then this is really just the terminal point right here. And knowing this terminal point is nice because we can always drop an altitude back to the x-axis and we can come up with what we call the horizontal and vertical component of this vector. So this is right here, this is the horizontal component, comma, the vertical component. And it basically tells you how far left and right, how far up and down you need to go in order to get to that terminal point from the origin, okay? So if we're going to find this here, and it's not already in component form, it says that what we're going to do is we're just going to take x2 minus x1 and y2 minus y1, and kind of illustrating that up here, we're saying if this is some x2, y2, and x1, y1, essentially what you're doing by taking this y2 minus y1 is you're finding this distance here. Between these two y values. You're taking the second height minus the first height here. If this is y2, this is y1. And in terms of the x values here, we're saying that this is x1 on the x-axis, this is x2 right here. You're saying that this distance right here is actually x2 minus x1. So if we were to subtract those off, then essentially it would be as if our vector did start at the origin and then we have its terminal point. We would just have these two values here that we could just drop in right there. So let's say, for example, we have a vector u and its initial point is at 2, -5 and the terminal point's at -1, 3. We want to write this in component form. So 2, -5 and -1, 3. I'm kind of a big advocate for drawing a picture. So we're going to go over to this GeoGebra program. 2, -5, -1, 3. We're going to make a vector that starts at 2. We have 2 down 5 and it goes to -1, 3. And so here's our vector right here that we can see. What we want to do is we want to write this in component form. So essentially what I'm saying is if we were to just copy and paste this vector in, we get this new vector. These two vectors are equal. And we're saying that if this were to have started at the origin, where would its terminal point be? And we see that it is this point -3, +8 here. Okay, we could have determined this by looking at this other vector down here. To get from point A to point B, I'd have to go left 3 and up 8. So the same thing I would do here. So eyeballing this is kind of an option, but we want to use this formula right here. So essentially, I'm just going to write this out. We had an initial point at 2, -5. This was our first point, and our terminal point was at -1, 3. So we have x1, y1, x2, y2. And if we want to put this in component form, we're saying it is the change in x values, comma, the change in y values. So we say change in x values, we have x2 minus x1. And we could say, you know, I could represent this with parentheses here. And then we could say, all right, well, y2, which is 3, minus y1, which is -5. We get this component form here of -3, comma, and this would be plus a positive now, +8. So essentially, we'd say that some vector, if it started at 2, -5 and went to -1, 3, might as well start at the origin. And if it started at the origin, then it would just mean that it goes left 3, 1, 2, 3, 4, 5, 6, 7, 8, and up 8, and that those two vectors would be the same vector. Okay, so that would be the component form of this that just basically indicates where it terminates because we assume it starts at the origin. Cheers.